Hello guys, I hope you've all been well. Welcome back to Manalasak. Now this is a video for Algebra. You'll need this video for June exams. You'll need this video for final year exams, November exams, right? So every time you have to do Algebra, please come back to this video and do this. Now Algebra is one of the most important things that you're going to write about in paper 1. It's heavy. It weighs a lot of marks, a lot. So you can just, for June exams most especially, you can just study Algebra alone and pass the exam, right? The way it's so important. But in November, it's a different story, but it still weighs a lot of marks, right? So now, in this paper, like I told you in class, I'm going to study Algebra using past papers. Now, remember how I told you, when you study past papers, you don't open a paper, study it from the beginning and finish it at the end of the paper in one day. No. What you do is that you download the past 5 papers, the previous year papers, like for the past 5 years, right? And then what you do is that you lay down all your question papers for the past 5 years. You do all the question ones. If it's in June where you're studying, you're going to do all June papers for the past 5 years. You do all question ones in all the papers. Afterwards, you come back, you do all the question 2s. Then you do all the question 3s. Like that. That's how you master the question paper. And that's how you master topics. So, this is what I'm going to do now in this video. I'm going to do the same thing that I'm telling you about, right? So, as you are starting, we need to start things in order with a disclaimer. Now, the disclaimer for my videos is that for you to get the best out of my videos, this is me tutoring you now. This is the most in person I can get to you, right? So what you need to do is that you need to have a pen and paper and a calculator. I know in the previous grades, especially grade 9 and grade 8, we used to advocate for mental math. But for these higher grades, a calculator needs to be your friend. You need to know how to use the calculator. Use the calculator as much as possible to save yourself some time. There's no glory in being able to multiply 5 by 27 in your head. There's no point. If you can, that's great, but there's no point for it. Okay. So, make sure you attempt all the questions on your own before you start, before you continue to see my solutions. And then when you replay, you see where did you go wrong. And if maybe your solutions are different to mine, you can contact me and I'll validate your solutions. So, again, when you open a question paper, immediately when you enter the exam, the first thing you do is that you restart your calculator. Now, your calculator needs to be in this format. It's not supposed to have an M there or any other things. It's supposed to be like this. Only have these 2 things, this D here and the math here. Right? Even if it does, when you turn on your calculator, before you start anything in the exam, you restart it. You press Shift 9 3 equal sign AC. Done. Then you can start the exam. Otherwise, you might get the wrong answers. Okay guys, we are 3 minutes into the video. Let's start now. So we'll first start with the June 2024 Gauteng paper. Right. So in this paper, this is what they had in question 2. Remember we did all the question 1s in the previous video. Right. Okay, let's move on. So I have 2.1.1 whereby it says we should simplify 2b into b minus 5c, and that bracket is being squared, right? So what are you supposed to do here? You're supposed to use BODMAS, right? You know this thing. So you're going to leave the 2b outside, and in this bracket you're going to write it twice, which is b minus 5c into b minus 5c, right? Afterwards, you FOIL this, right? When you FOIL this, you're going to have 2b outside the brackets. You multiply first terms to get b squared. You multiply outer terms to get negative 5bc. Remember to write your variables in alphabetical order. Then you multiply inner terms, negative 5bc. Then you multiply last terms, negative and negative, that's a positive. 5 and 5, that's 25. C and c, that's c squared. Right? And then afterwards, we are not done here. We add the like terms, right? Before we distribute. So I have 2b into b squared. These like terms will give me how much? Negative 10 bc, and then I have plus 25 c squared, close brackets, right? And then let's divide this here. I'm going to have to FOIL this. When I FOIL this, let me choose a different color. When I FOIL this, I multiply this with this. Let's start with this, the first one, 2b and b squared. That will give me 2b raised to 3, right? Wait, I might not have enough space. Let me write it below. I'm going to have here, as I said, 2b raised to 3. And then afterwards, I multiply this term with the middle one. I start with the signs, positive and negative, that's negative. 2 multiplied by 10, that is 20. And then b multiplied by bc, that is b squared c, right? Then I take this term outside afterwards, I multiply it with this all the way in front there. So I have 2 multiplied by 25, numbers first, wait, signs first, positive and positive, that's positive. 2 and 25, 50. B and c squared, that is bc squared. Right, so that's it. This is how I want you to do it. Easy, right? Now let's go to question 2. Now question 2 wants us to do the following. Now what I'll do is that I'll put this here. Let's use this. I'll put this down here, copy the question because I need space, and then afterwards deal with it. So the question says, 2.1.2, remember to number your questions correctly. I have 3x minus 2 multiplied by 3 raised to x minus 1. Those are exponents. This all over 3 raised to x plus 2, and then that whole thing plus 2 multiplied by 3 and x plus 1. There we go. Let me remove this now. So actually this question from the question paper, they made a mistake on this part here. This was supposed to be 3 raised to x, not 3x. This is what it was supposed to be. So which means here I have to rewrite this as 3 raised to x. There we go. Right? Hope we're good. So now we can do it. Now I'm sure your question is, what will happen if when I get to the exam there's an error on the question paper? Now what happens is that if the question paper has an error, you will be awarded full marks, but you need to attempt to answer the question for you to get all the full marks, right? So if the question has an error, you'll be awarded all the full marks. You won't be penalized. So what's the first thing to do here? The first thing is that we need to break this 3, right? And then we're going to break this 3 apart also, and we're going to break this 3 apart also. Now we're working with exponents here. So I have multiplied by 2. This part will be 3 raised to x multiplied by 3 raised to negative 1. All this over. When I break this apart, I'm going to have 3 raised to x multiplied by 3 raised to 2 plus 2 multiplied by 3 raised to x broken down into this one also. You see that? Then what am I expected to do from here? What I'm expected to do is that I'm supposed to see that on this numerator I have a 3 raised to x and a 3 raised to x. So I'll take the 3 raised to x and raise it out and take it out as a common factor. Right? Denominator I also have a 3 raised to x and I have a 3 raised to x here. So I'll also take these ones out as a common factor here. By the way, do not cancel this, right? Do not cancel them. Most important. I'm just showing you what am I doing here. Oops. I'll fix that now. So moving on. So since I took out the 3 raised to x here, I'm not left with 0, I'm left with 1. Minus here on this part here, when I take out a 3 raised to x, I'll be left with this 2 multiplied by this 3 here, which is 3 raised to negative 1. Here when I take out 3 raised to x, I'm left with 3 raised to 2. Plus here when I take out 3 raised to x, I'm left with 2 multiplied with 3 raised to 1. Hope you're good there. So, what am I getting? Firstly, the 3 raised to x as a denominator will cancel out with the 3 raised to x as a numerator, right? So, and then what happens? Then I need to simplify this numerator, right? Because I cannot cancel this 2 and this 2. You cannot cancel numbers that are in a binomial. You can only cancel numbers that are in a monomial. So, there we go. I have a 1 minus. I need to fix this issue here because there is some confusion going on. So, I have a 2 multiplied by 3 raised to negative. Now, 3 raised to negative 1 is the same as 1 over 3. So, I'm going to write the 1 over 3 here. Now, since this is a fraction, I'm going to make 2 also a fraction, right? And bear in mind, we are still on the numerator level. So, that is that. All this over the denominator. The denominator is 3 squared. What is 3 squared? That is 9. Plus, I have what? I have 2 times 3. What is 2 times 3? That is 6, right? So, here I have 1 minus. Here I have 2 times 1, which is 2. Here I have 1 times 3, which is 3. All this all over 9 plus 6. What is 9 plus 6? That is 15. Right. So how can I rewrite 1? I can rewrite 1 in terms of denominator 3. 1 in terms of denominator 3 is the same as 3 over 3. Minus 2 over 3. And all this is still divided by 15. Right. It might look like I'm taking a lot of steps here, but I'm trying to make you understand. Then I have 3 minus 2, which is 1 over, since they all have the same denominator, I write 1 denominator. And all this is divided by 15. Right? So I'm going to take this, which is 1 over 3. I'll write it here. Then this division line, I'm going to use a division sign for it. And then here I have a 15, so I'm going to say divided by 15. Now this is the same as 1 over 3 multiplied by, I rewrite 15 now in an inverse form, which is 1 over 15, right? And this is equals to 1 times 1, which is 1, 3 times 15, which is 45. This is your final answer. Good, right? Hope you all got here also. Now let's go to the next question. Oops, my bad there. Let's fix this. Oops. How do I fix this? There we go. Now, next question. So next question, what I have to do is factorize completely. Now, factorizing, especially something that is this type of factorization, grouping of terms, sometimes it can be trial and error. And I remember someone sent me this question, and I hope this will answer you well as a video. So why am I saying this is trial and error, right? So sometimes you might feel like factorizing it right away. Let me show you what happens. Like, let's say I'm in the exam and then I'm trying to factorize this. I'm saying, oh, this is grouping of terms, so I associate the two things. I put this in brackets and I put this in brackets with an addition in between. Remember, it's supposed to be a binomial. So I have an a squared minus ax plus negative 1 plus x in brackets, right? Afterwards, there comes that process whereby I need to take out common factors. When I take out a common factor here, I'll say a as a common factor. I'll be left with a minus x. And then here, the only common factor I can take out is what? Is negative 1. And then I have 1 minus x. But then now I cannot proceed to the next part. Why? Because this bracket and this bracket are not the same. So which means I do know what form of factorization is, but my method of applying that factorization didn't work out. So now I need to go back and rearrange what I was given. So let's do that. So what I was given is, for 2.2, I had a squared minus ax minus 1 plus x. Right. So, given what I had there, I'm like, no, this thing, the way I'm given to factorize it, it's not factorizable. Let me try to group things differently. Right. So, I'm like, okay, I'll take this a, I'll group it with this negative 1 here. So, I have a squared minus 1, right? And then afterwards, I'll take this negative ax, I'll group it with this one. I have negative ax plus x there, right? Then now I group them. I have a squared minus 1 in brackets plus these ones in brackets here, which will be negative ax plus x. And then I want to see whether this is factorizable, right? So I'm going to say, wait, what I see here is difference of two squares. Okay, so I'm going to do that. I'm going to say open two brackets for that part, which is difference of two squares. Factors of a is a and a. The signs will be positive and negative. Factors of 1 is 1 and 1. Plus, here, is there anything I can factorize there? Well, I can take out the negative x as a common factor. So here I'll put negative x, and then inside these brackets I'll be left with a minus 1. Do you see that? Now I have two signs here in between. I'm not supposed to have two signs. What do I do with the two signs? I make them fight, negative and positive. I'll come out with a negative. Boom, there we go. Right. And then afterwards, what am I seeing? I'm seeing that, oh, wait, here I have common factors, right? I have in this term, I have two terms. I have this term and this term. In this term, I have a minus 1. And in this term, I also have a minus 1. So I take out a minus 1 as a common factor. So I have a minus 1. Took it out as a common factor. Now what am I left with? From this thing, the first term, what I'm left with now, I'll put this bracket. I'm left with a plus 1 minus x. There we go. Fully factorized. Remember, guys, in grade 10 going forward, you need to master factorization. And this is what we meant by that. So moving on to the next question. I'm done with question 2 from 2024 Gauteng. It took me a little bit more time. This thing was like 8 marks. I was supposed to do it in less time, but there was a lot of explaining there. I hope you'll forgive me. Now let's go on to the next part. We have a question here, which is question 3. This is still algebra, and I'm still on the June 2024 Gauteng paper. Now let's do it. Starting with the first question. Now this is not simplifying. This is equations. We are solving for x here, right? And solving for x is one of the nicest thing I love in algebra, because it has like almost everything. It has exponents. It has everything. Okay, let me stop talking and do it. So I have 3x squared is equals to 2x, right? What I need to do, what you don't want to do, is reduce the number of x's you have. Let me write this properly. What you don't want to do is reduce the number of x's you have, right? What do I mean by that? What I mean is that the examiner will put this, and trust me, it will also be there in the grade 11 paper. And the examiner will do this knowing very well that there is someone who will fall into the trap of saying, let me divide this by x and divide this by x. This cancels that, and then I'm left with this part. I'm left with 3x is equals to 2, therefore x is equals to 2 over 3. They know someone is going to do this. That's why this question will always be there, especially as question number 1, right? So what you need to do is not to reduce the number of x's you have. What you do is that you solve for all the x's. What do I mean by that? You'll take this and send it to another side. So you have 3x squared, 2x goes to another side, that's negative 2x. Now on the right side, you are left with 0. And then what do? Then you take out your common factor. What is common between this term and this term? That is x. You take out x as a common factor. On this part now, you are left with 3x. Then you have a minus. On this part, you are left with 2. This is equals to 0, right? Then you equate each and every part to the right side. Now x, you equate it to 0, which is the right side, or you see now you have multiple x values, or you're going to say 3x minus 2 is equals to 0. There we go. And then you isolate everything from x. You're going to say 3x is equals to, you send this to another side, it's going to be positive 2, right? Let me use this space. I already have x as 0. Let's put that. And now I'm solving for this part, which is 3x is equals to 2, right? You have two solutions. When I remove x here, I'll say this divide by 3 and this divide by 3. Therefore, my x on this part will be equals to 2 over 3. There we go. You have two solutions. And then afterwards, you have to test all of them. You have to put all of them on a calculator and see if they work out. So there we go. I'll start with the 0. When I say 3 into 0 squared, right, I'm substituting on this one here. This part here is supposed to give me 0, right? So there's minus, because there's a minus, 2x. So I'll say 2 into my x is what? 0. So I said what? This whole thing must give me 0. And when I press the equal sign, it does give me 0. So it means now this answer is correct. It means this answer is correct. And I go to another one. I test it also. I must also put 2 over 3 every time I see x to see if it works out. So I'll put 2 over 3 here. 2 over 3. I go here again. I'll put 2 over 3. I'm supposed to get what? Remember, I substituted here. I must get 0. Voila, I get 0 again. So which means this answer is also true. Is it possible for one of the answers not to be true? Yes, it's possible. Right. So moving on to the next question. Now, this is like, I would almost say the final boss of algebra in grade 10. Right, this part here. And then we are going to go to it now. So in this situation, I'm going to just copy this, put it here so that I can write the question properly. The question says that is 3.1.2 7 over 3 minus x. This is equals to 5 over x plus 3 plus 4 over x squared minus 9. So now I can remove this question. I know that this is worth 4 marks, and please verify for me that I didn't make a mistake. I usually make mistakes. Do not be surprised. Okay, so now what do we have? First of all, I cannot work with different denominators. I need to have same denominators. Now, how is that possible? I don't know, but I just know I need to have same denominators. So I'll work that out and see if I will be able to do so. I'll start here. I'll do things very slow, step by step. And if you can put this somewhere and get it in shorter steps, it doesn't mean I'm wrong. I just want to explain it thoroughly, right? So here I have 3 minus x. There's nothing I can do on the left side, to be honest. So I'll just write it like that. And then here I have x plus 3. There is also nothing I can do to this fraction. It's just like that, right? Plus, however, this part here of the fraction, I can factorize this. This denominator here is factorizable by difference of 2 squares. So I'll try that. Factors of x squared, I have x and x. Because it's difference of 2 squares, one bracket will be positive, the other one will be negative. Factors of 9, that will be 3 and 3. Make sure your division line covers the whole thing. Right. So afterwards, what am I saying? I know that I need to find the LCD at some point. I hope you still remember this. I need to find the LCD. Now, for me to find the LCD, I need to find the LCD that represents all the denominators, right? So I know that first my LCD needs to have an x plus 3. And my LCD needs to have an x minus 3. Right? So x plus 3 is represented, x minus 3 is represented. So this fraction is well represented. Now let's go to the second one. In this fraction, it is a denominator of x plus 3 and it's represented, right? Okay, let's go to the last fraction. Here we go. Here I have a denominator of 3 minus x and there's no 3 minus x here. However, 3 minus x almost became similar to x minus 3. So I need to take out a common factor of a negative here so that this becomes represented in my LCD. So I'll do that. I have 7 over, take out a common factor of a negative. Now it will make x to no longer be negative but be positive, and 3 will no longer be positive but it will be negative, like that. This is equals to 5 over x plus 3 plus 4 all over x plus 3 and x minus 3. Now remember what we always used to say: when you see a binomial as a denominator, put it in brackets, right? So now this denominator we already said it's represented here. This denominator we also already said it's represented here, and this one we needed to make a few changes, but eventually this part x minus 3 gets represented there. And then what am I going to do with this negative? Well, a negative that belongs to the numerator, to the denominator, I can always send it to the numerator, right? So I'll do that. I have negative 7 over x minus 3 is equals to 5 all over x plus 3 plus this x plus 3 x minus 3. Now my denominators are perfect now. They can all be represented with this LCD. So in my answers now, I can safely say my LCD is x plus 3 and x minus 3. And all denominators here are well represented in that LCD. Hope we're good. So now what am I supposed to do? I'm supposed to eliminate those denominators because I cannot work with denominators, right? All that job was to make denominators the same so that now when they're the same, I can just eliminate them. Okay, let's do that. To eliminate them, I have to multiply everything by the LCD. Okay, so I'm going to say negative 7. There's a lot of work. Negative 7 all over x minus 3. And then I'm going to multiply this by the LCD. So multiplied by x plus 3 and x minus 3 over 1, right? This is equals to, let me write this here because I won't have enough space. Please forgive me, guys. I want to create enough space for the mess that I'm about to write now. Like I need space. Okay, this part here, you see, I have negative 7 all over x minus 3. I'm going to multiply this by the LCD. The LCD is this one. So I'm going to say numerator LCD. X plus 3, x minus 3, all over 1, right? Then I go to the next guy, which is, I have equal sign here. And then I have this guy, which is 5 all over x plus 3. What do I do to this guy? I also multiply him with the LCD. So I have x plus 3 and x minus 3 all over 1. All right, done with this guy, done with this guy. So, and then I go to the next guy, plus. See this plus here? I write this guy down, which is 4 over x plus 3 and x minus 3. What do I do with this guy? I multiply him with the LCD also, which is x plus 3, and x minus 3. That was a lot, right? Let me clear some space here, right? So in the meantime, make sure that you digest all this. It's making sense to you. I know that this video is going to be long. I can see that, but trust me, it's very much worth it, right? So let me do this. Now I need to, since I multiplied everything with the LCD, I need to simplify things. Take out this. X minus 3 will be cancelled by x minus 3. I no longer have a denominator. Good job. Now x plus 3 will be cancelled by x plus 3. No longer have a denominator. Good job. X plus 3 cancels with x plus 3. X minus 3 cancels with x minus 3. No longer have a denominator also. Good job again. Now what am I left with? I'm left with negative 7 multiplied by this binomial that is left here, which is x minus 3. This is equals to 5 multiplied by the binomial that is left there, which is x minus 3. No longer have a denominator. Plus, I'm left with 4 multiplied by, that is nothing. This is just ones, right? So I no longer have anything just there. So I have to distribute this. Negative 7 times x, that's negative 7x. Distribute again. Negative 7 times negative 3 starts with the signs. Negative and negative, that's positive. 7 times 3, that's 21. And then, yeah, that's that. Equals to, distribute this. 5 times x, that is 5x. Distribute again. Positive 5 times negative 3, that is negative 15. Plus 4, right? Then afterwards, deal with like terms. I have negative 7, guys. This is long, but it's nice. And this, right? And then I have 5x. I add these two like terms. I'll get a what? Negative 11, right? Send everything to one side. I'm going to send this 5 right up here, right? So I'm going to have negative 7x. When the 5 comes here, it's going to also be negative. This is equals to, I have a negative 11. There it is. I'll take the 21 and send it to the other side. Positive 21, when it gets here, it becomes negative. Now it's negative 21, right? Whew. And then what do I have? I have negative 7x, and that is negative 12x. This is equals to negative 11, negative 21. I'm lazy to calculate. That is equals to negative 32, right? I wish it was 36, but then we don't always get what we want, right? And then I divide both sides by 12, by negative 12, so to say. So I'll use a different color here. There we go. There we go. Divide this by negative 12, divide this by negative 12. I'll have x is equals to negative and negative, they cancel out. I'm left with 32 over 12. Now I'm so lazy to simplify this on my own. I'll just put this on a calculator. I have 32 over 12. Oops. 32 over 12. There I get 8 over 3. Now, oops, let's write this properly. The pen is tired now. How much was that? 8 over 3? Yes. 8 over 3. Now let me tell you something. Do you understand how many steps we went through just to get to this answer? Now trust me. If when you test this answer, because you have to test it if you feel like it, to be honest, according to me, if you feel like it, you can test it. Now, you need to go back and test this answer. And when you test this answer, you find out it's wrong, please leave it. Because you don't have time to go through all that again just to fix one mistake. You try it once, whether you won or you fail, you're done. You get what I'm saying? You attempt this type of a question once because it was 4 marks. You're supposed to do it in 4 minutes. It would have probably taken you 6 minutes or 7 minutes. If it's wrong or it's right, just leave it like that. You touch it once, you're done, right? So let's move on now. To the last question, which looks like an exponential question. A very nice exponential question. From the June paper, we have 3.1.3, which says you have 16 multiplied by 2 raised to x minus 1. This is equals to 0.5, or would you look at that? They're throwing decimals, okay? X minus 4. And this is 4 marks. Now let me eliminate this question. There we go. Now, what's the problem? You need to ask yourself that. The problem is this 0.5. It's not comfortable to work with 0.5 when we have exponents. So 0.5, I'm going to convert this. What is 0.5? 0.5 is a half. What is half? Half is this, right? So I'm going to rewrite this as a half, that is a fraction. I'll write this in exponential form. If you don't know how to do things in exponential form, the calculator is your friend, right? 16 equal sign, shift, fact. What's fact? There. You see that? It's written fact in orange somewhere there. You press that, it tells you that this is 2 raised to 4. You go there, you do it that way. I have 2 raised to 4. That's my 16, right? Multiplied by 2 raised to x minus 1. This is equals to, what is 0.5? I already said it here. That is 1 over 2. Right. All this is raised to x minus 4. Do we see that? Let's choose an eraser here. There we go. Now, afterwards, I can multiply these two things. So that is 2 raised to 4. I add these exponents, which is x minus 1. This is equals to, I rewrite this in exponential form. 1 over 2 in exponential form is the 2 raised to negative 1. 2 raised to negative 1, that is that. And I still have these exponents outside the brackets, this way. Right, we erase this. And then I have 2, I have a 4 and a negative 1, that is 3, plus this x. This is equals to, I distribute the negative to this. So I have 2 raised to negative x, multiply with this, positive 4. And then bases are the same. I drop them, right? When I drop the bases, I'm left with 3 plus x is equals to negative x plus 4. It's becoming simple algebra now. I'm going to send x to this side, which means I'll have x. When this x gets here, that is plus x is equals to, I have a 4. When I send 3 to another side, it becomes minus 3. This 2 will give me 2x is equals to 4 minus 3, which is 1. Then I divide both sides by 2. My x will be equals to 1 over 2. Beautiful 4 marks question there. I hope you also enjoyed it. Right. So that was that. I hope you guys really enjoyed that one. Now I need to move on to the next paper, which is this one. Still the Gauteng paper, but now I'm on question 3.2. You see that? And now I'm dealing with inequalities. That Gauteng question paper was very nice, guys. Come to think about it, it was very nice. So for this one with inequalities, what am I supposed to do? Now you solve for inequalities similar to how you would solve for equations. Let me start with 3.2. Point 1. Right, it says solve the inequality. I have 2 minus 3x over 4. This is less than 14. Right, what do? I'm going to take the 2 and send it to the next side. So I have 3x over 4. I have this sign. I have 14 minus 2. Right, this will give me 3x this. 14 minus 2, that is 12. Are we good so far? then what am I supposed to do? What I'm supposed to do is that I'm supposed to multiply both sides by 4 to get rid of the denominator. So numerator 4 multiply with this, and I'm going to have 4 multiply with this. So denominator 4 will cancel with numerator 4. I'll be left with 3x, and I have this sign, and I have 12 times 4. If you already know that 12 times 4 is 48, that's good, but you can never be sure, right? Just use your calculator, guys. 48. Okay, there we go. 48, right? And then afterwards, I'm going to have, oh, I forgot a critical factor there. You see this negative here, minus, supposed to stay there, minus, supposed to stay there, minus, I had a minus in front, right? So it was a minus, and a minus there, right? So now I remove this minus and the 3, all of them to the right side. So that's what I'll do. So I'll divide this part by -3. I also divide this part by -3. So negative and negative will cancel out. 3 and 3 will also cancel out. I'm left with x. But remember what happens when you divide with a negative, this sign starts changing. It now faces the other way, right? And then you have 48 over 3. Is 48 over 3 simplifiable? Only one way to find out. 16. You see that? So this is greater than -16. That's your answer. Because positive divided by negative is negative. 48 divided by 3, that's 16. So that's your final answer. Nice inequality question. Nice inequality question. Afterwards, it says to you, let's go to that question. Write down the first natural number that will satisfy the inequality. Now, this might be that level 4 questions for grade 10s, simply because of the English, to be honest. There's nothing heavy here, right? I just know most kids are scared to read questions. So 3.2.2, number 1, let's clarify what are natural numbers. Natural numbers, we're talking about numbers that you would use when you naturally count. 1, 2, 3, 4, 5, 6, and all those numbers, right? Those are natural numbers. So they want the first natural number that will make this statement to be true. Now this statement, now it has the left side and it has the right side. What is the left side? The left side says 2 minus 3x all over 4, right? And then this is saying less than, right? The right side is what? Is 14. Now, if the left side, when I substitute a natural number, is less than 14, then that number would be true. Let's start with the first natural number. Let's start with 1 as the first natural number. If I put 1 in this situation, will it make the statement true? Only one way to find out. 2 minus 3, where there is x, I put 1 all over 4, right? And afterwards, I use a calculator for that, and I want to see if that is true. I have 2 minus, 2 minus a fraction, and that fraction is 3 multiplied by 1 all over 4. This is equals to 5 over 4. This is equals to 5 over 4. Now, does it make this statement to be true? Is this number less than 14? Yes, it's less than 14. Therefore, the number that will make that statement to be true is 1. That's the first natural number that will make that statement true. So 3.2.2, that is 1. The answer is x is equals to 1. See how easy is that? Beautiful. Now to the next part. Now we have to go to the next question, which is about simultaneous equations. Simultaneous equations. I know you guys hate that. You hate the word to hear that word, simultaneous equations. But to be honest, just do it. Normal algebra there, nothing fancy. You will realize that this is beautiful. This is beautiful maths. Right, 3.3. You have 2x plus y is equals to 8. We'll call that our equation 1. You have 2y plus 3x is equals to negative 2. We'll call that equation 2. Right, now bear in mind, you choose any equation to be equation 1 and any equation to be equation 2. Let's remove this. This is how much? 4 marks. For grade 10s, I would actually give you guys 5 marks for this, but you know I'm not the examiner. So, what is the first step? The first step is to choose one thing in the simplest form, the simplest one that you can make the subject of the formula, right? So I'll choose equation 1. Equation 1, the variable that is very easy to isolate here without getting any complicated fractions is y. I can isolate y without getting any complicated things. So I'll do that. Let's choose a different color for that. I'll take this and say 2x plus y being equals to 8. I isolate y. I'm going to have y is equals to. I send this to another side. I'm going to have 8. 2x when it gets there, it's minus 2x. Now that's my equation 3. Do you see that? So far I used equation 1 to create equation 3. Right. Now I need to substitute equation 3 into the equation I haven't used so far. So I used 1, I used 3. It means I'm substituting equation 3 into equation 2. You see that? Now what am I going to have? I'm going to have 2y. You first start by mentioning the equation you're substituting into. It's so important, right? Make sure you don't forget the step of mentioning equations, guys. 2y plus 3x is equals to negative 2. That's your equation 2. Then you substitute 2. It means now every time we see y, we are going to substitute with this binomial here. So here I have 2. Instead of saying y, I'll say 8 minus 2x plus 3x. This is equals to negative 2. Right? Then I distribute, removing brackets, bottommost. 2 times 8, that is 16. Positive and negative, that's negative. Therefore 2 times 2, that is 4, and I attach this x here, and then plus 3x, this is equals to negative 2. Right? What do? I add like terms. Here are like terms there. See? Beautiful maths. Beautiful maths. 16 is equals to negative 4 plus 3, that is negative 1x. Right? This is equals to this negative 2 that you see here. You see that? Then 16 goes to another side. I'm left with negative x is equals to negative 2. When 16 gets here, it becomes negative. So that's negative 16. Right? So I have negative x is equals to negative 2 and negative 16. That is negative 18. What do? I divide both sides by negative 1. So that I can remove the negative. Divide by negative 1. Divide by negative 1. So this negative gets cancelled. I'm left with what? X is equals to negative and negative, they cancel. I'm left with 18. You see that? Now here's what I'm going to do afterwards. I'm going to take one of the equations and find the value of y. That's what I need to do now. So I'll take this simplest equation, equation 3, and use it to find y. So I'm going to say sub x into equation 3. Right, I'm directing the marker. I want him to see what am I doing. So I keep on writing the steps. Sub x into 3. So I write down equation 3. What is equation 3? Y is equals to 8 minus 2x. And I tell him, I show him, this is equation 3. Then I say y is equals to, where I see x, I substitute with 18. So 2 times 18, it is y is equals to 8 minus 2 times 18. Therefore, y is equals to, you know, I'm a person who doesn't like hard labor. Right? So I have 8 minus 2 times 18, close bracket. No need for hard labor. Negative 28. So my y is equals to negative 28. There goes my 4 marks. This was a beautiful June paper for 2024, guys. Gauteng really gave people a beautiful paper. Right. So I hope that was very nice. And then now I need to throw in more algebra. Remember we said algebra will be worth a lot, guys. A lot of your paper will be dependent on algebra. So you need to take it seriously. Right? So now, what do we have here? For 1.2, we need to factorize. Now, this is basically factorization. But now I'm out of the June 2024 paper, that one that we enjoyed. I'm now doing the 2022 paper, right? So I'm just going to slice through this one. I don't think it's a problem. Let's quickly do it. So 1.2.1, I have 2x squared minus 32. Factorize fully. What is the first thing I can do there? Now remember, the trick is the examiner knows that you will see that, wait, 2 is a common factor, right? You take out 2 as a common factor, you are left with x squared minus 32 divided by 2, that is 16. The examiner knows you leave it here and you got the first mark. But the question doesn't end here, and there's a high chance that you might not even get this mark. Right? The examiner knows that when he gives you this question, you will be too excited and you will answer it and leave it here in the middle. But what are you supposed to do? You're supposed to factorize this bracket further. You open 2 brackets for that bracket that you see here, because this is difference of 2 squares. So, oops, let me charge my thing. Right, let's move on. So now here you'll write factors of x squared, which is x and x. Because it's difference of 2 squares, one bracket is positive, the other one is negative. Factors of 16, that is 4 and 4. And this is what ends you the full 2 marks. Right. So I hope that's easy. I hope you see it as easy as I see it. Now, if you realize, this will be like the second time we get a question that is about factorization. And then it has grouping of terms. And it's tricky also. The other one we had was this one here. This one here. And then we maneuvered. It was tricky, but we did it. And then here we have another one again, which is grouping of terms. And it's tricky again. Right? So be careful of that. So here's what the examiner expects from you here. He expects you to know that, you will see that, okay, 6a minus b, this is grouping of terms, but I cannot take out common factors from here. Right? And then remember, you are timing yourself. If you see yourself thinking for more than 3 minutes, leave the question, move on, so that you can have time for things you know. Right? So I have 1.2.2. So I have 6a squared minus b plus a into 2 minus 3b. What I will do is that I'll multiply this first. So I'm having 6a squared minus b, a times 2, that is positive 2a, a times negative 3b, that is negative 3ab. Remember to put things in alphabetical order, right? So I distributed this. Why? Because I want to rearrange these things. I want to rearrange them in a way that can work out for me. So this 6a squared, let me put it here. I'm going to group it with this 2a. So I'm going to say plus 2a. And then this negative b, I'm going to group it with this negative 3ab. You see that? What am I going to have now? I'm going to group these ones together, which is 6a squared plus 2a. Plus, I'll group these together. I'll have negative b minus 3ab. There we go. Afterwards, I take out common factors in these brackets. Common factor here is 2a. When I take out 2a from this part, I'll be left with 3a. Right? When I take out 2a here, I'll be left with what? Not 0. If I take out 2a here, I'm left with 1. Right? And then here, what is the common factor? Let me use a different color because this is so nice. I take out negative 3b because there's b here, there's b here. So I'm like negative 3b. What am I being left here with? I'm left with 1. What am I left with here? I'm left with plus. Sorry, this is not a common factor. 3 is not a common factor. I'm sure someone is looking there and is like, what? What is they saying? The common factor here is negative b, not negative 3b. I'm taking out a common factor of b because I have a b here and I have a b there. Hope it makes sense, right? So I take out negative b because they also all have negatives, right? When I take out negative b as a common factor, here I'm left with 1 plus. When I take out negative b in this situation, I'm left with 3a. There we go. Right? And then, what am I having? I'm rewriting this in a way that makes sense. I have 2a into 3a plus 1. I have negative b into, I rewrite this so that it looks like this. I start with the 3a, I come with the positive 1 afterwards. And then now these two brackets look the same. What am I supposed to do? I'm going to take these items. The common factors, I'll group them together. So that is 2a minus b. Afterwards, the common brackets, I'll group them together, which is these ones. I'll have 3a plus 1. See how nice is that? How nice is that? Like, maths is beautiful, guys. Okay, let me move on. Let me move on, guys. Let me not waste your time. We have 57 minutes into the video. I'm entering now the June 2022 question 1.3. Now we are going deep in it now. Simplifying this, number one, it's supposed to be the easiest thing you're supposed to get in that question paper. Multiplying a binomial with a trinomial, right? Let me write it here. You have x minus 1 into x squared plus x plus 1. You're going to take the first thing and multiply it with the whole trinomial. That is x multiplied by the whole trinomial. The next part, you're going to take the second term, which is negative 1, and multiply it with the whole trinomial. That is negative 1 multiplied by the trinomial. This way. The next step, you continue the journey. X times x squared, that is x raised to 3. X times x, that is positive x squared. X times 1, that is positive x. Then you come to the other part also. You're going to have negative times x squared, that is negative x squared. Negative times x, that is negative x. Negative times 1, that is negative 1, right? Then you work with like terms. I'll choose a different color here. I have a negative x. I have a positive x. These things, they cancel out. I have a negative x squared. I have a positive x squared. These things, they cancel out. What am I actually left with here? I'm left with the first part here, which is x raised to 3, and I'm left with the last part, which is negative 1. There we go. 2 marks, guys. Beautiful 2 marks for you. Next question. This is like the last thing I'm touching, so don't worry, guys. I have the following. 1.3.2. 1.3.2, it says, okay, we did something like this and it took us a lot of time and it's still going to. That's the funny part about it. I have x plus 7. Like, we did something like this. Let me see if it's not exactly the same thing. I think it was somewhere here. Yes, this question. It came from this question paper. Wait, why is this freezing? Oops. Yes, it came from this one here, the one that I'm highlighting here. And it was a long thing. We even erased and ended up with an answer like this. And then I actually made a mistake here. I cancelled x minus 3 with x plus 3. If you saw it, I hope you did, right? So yeah, but then that's that. I hope on this one I won't make the same mistake. Okay, let's move on. I'm writing the question down. Okay, there we go. 5 marks. 5 marks this thing. Alright, hope I copied the question correctly. No errors there. Then yeah, I can move forward. I can remove this. Then we start. What is the first thing? Firstly, I can see that this is factorizable. I'll start with that. I'll try to write this on the side so that my planning goes well. Take out factors of x squared, which is x and x. I have the last term being negative. When the last term is negative, it means I'll have opposite signs, right? I need factors of 6 that can give me 1, so that is 3 and 2. But my middle value is supposed to be negative, so which means the bigger number will be negative, and this way, right? Hope you can factorize. So I'll have this. So if this will be my factors, this part will be represented here, and this part still needs to be represented somewhere here, but we'll see how that happens, right? So let's do that. That was my plan. You see how fast was that? So I have x plus 7 all over. I factorize this, which is x minus 3, and I have x plus 2 minus, there is nothing I can do here. I have 3 all over x minus 3, plus I have 2 all over, the beautiful part here is that I can take out a common factor, so which is 2, and I have x plus 2. You see that? So now what do I see? I see that, oh, this is similar to that bracket. The only extra thing here is the 2. You see that? But I'll deal with that. I'll deal with that very nicely. So LCD is what I need. I need to represent x minus 3, which is x minus 3. I need to represent x plus 2, which is x plus 2. So this whole fraction, its denominator is represented. Now to the second fraction, x minus 3, is it represented? Yes, it is represented. And now to the next part, the denominator of the third fraction, is it represented? X plus 2 is represented, but the coefficient 2 is not represented. So I'll put multiplied by 2 here. You see that? And then afterwards, we simplify how we multiply each and every part by the LCD, and that's the long story there. So x plus 7 all over x minus 3 into x plus 2. This will be multiplied by the LCD. What is the LCD? X minus 3, x plus 2 multiplied by 2. Then to the next part. What do I have? I have 3 all over x minus 3. I'll multiply this with the LCD. Here is the LCD multiplied by x minus 3, x plus 2 times 2 over 1. Then to the last part, I have plus 2 all over 2 into x plus 2, right? Multiply this by the LCD, which is x minus 3, x plus 2, and 2 over 1, right? So let's open this part. I don't make a mistake. So x plus 3 cancels with x plus 3, x plus 2 cancels with x plus 2, no more denominators, good. X minus 3 cancels with x minus 3, no more denominators, good. 2 cancels with the 2, x plus 2 cancels with the x plus 2, right? What am I left with? I'm left with x plus 7. This will be multiplied with the 2 here that is left, right? Minus 3. The 3 will be multiplied with, first things first, the 2 here. And then it will be multiplied with the binomial here. X plus 2, right? Plus, I have a 2 here. It will be multiplied with the remaining x minus 3. There we go, right? And I'll remove the top part to create some space. I actually like algebraic fractions. I feel like this is very entertaining to work with. You see, you're writing all the variables, all the complicated things there, and you're just enjoying maths, basic maths. Right, I actually like this part. So I have here to distribute this to that. So I'll have 2x and then positive 2 to 7, that is positive 14. And then 3 times 2, that is 6. And I still have to multiply it with this bracket. And then I have a plus here. I have 2 times x. I have a 2 times negative 3. Right. And then I can remove this part. This is peak algebra, guys. The most enjoyable algebra you'll ever do. I have 2x, right? Plus 14, and then I distribute this. 6 and negative 6 and x, that's negative 6x. Negative 6 and positive 2, that's negative 12. Plus 2x minus 6. My handwriting is even collapsing. Oh, I'm so tired. And then I have 2x and 2x, that's 4x. And then I'll add 4x. Okay, let's do that. 4x, I'll add it with negative 6x. Right? And then I have, let's say, positive 14. And then I have negative 12 and negative 6. That's negative 18. So this and this will give me negative 2x. And then 14 minus 18 will give me negative 4. So that's my final answer. Negative 2x minus 4. If you did anything wrong, again, don't go back to see what did you do wrong. Just move on. You don't have time to revisit questions like this over and over again. They'll take too much time from you. And then what do I have? Another one, I have this last part here, which is exponential. I love exponential expressions. So let's do them. You have 1.1.3. I mean 1.3.3. Number your questions correctly. You have 4 raised to x plus 1. The last one we did, it had a question, it had an error from the examiner's 3. That was not my error. Okay, but at least we saw it and fixed it. And here I have 6 raised to 2x minus 1. 2x minus 1. Now, here's the tricky part about this one. Okay, this is 3 marks. Or let me just keep quiet. You'll see the tricky part. What's happening here is that I have base 4 and base 9. I need to rewrite those things properly. Right, so we're going to rewrite 4 in the simplest base. Now, if that gives you a problem, remember the calculator is your friend. Right, you're going to say 4, press equal sign, press shift, and then fact. Wait, let me fix that. You press 4 equal sign, shift, then fact. There we go, 2 raised to 2. Right, so this is 2 raised to 2. And then you have x plus 3 there. Sorry, x plus 1. And then afterwards, you write 9 in exponential form. What is this? 3 raised to 2. And then you have an x exponent that was there. Right? And afterwards, I have 6. Now, what do I do with the 6? You go to your calculator. You ask the calculator the very same question. 6 is equals to shift fact, that is 2 times 3. That is the best they can give you. So you go there and you write it that way. 2 multiplied by 3, and all this is raised to 2x minus 1. Right? Then you simplify these brackets here. You'll have 2 times x, that is 2x. 2 multiplied by 1, that is positive 2. Multiplied by 3 raised to, what is 2 times x, that is 2x. Right? All this over. Now I want you to bear in mind, let's use a black color here, that this exponent, this binomial exponent, applies to the 2 and it applies to the 3. That's what you want to do here. You give 2 the same exponents as you would give 3 those exponents. You see that? Now, when it's like that, now you take everything to the numerator. Right? You're going to say these ones are the same. So you'll divide them together, and these ones have the same basis. You'll also divide them together. So I'm starting with this now. This will be the main base. That will be 2 raised to 2x plus 2. Now when you divide powers with the same base, you subtract exponent. So I'll subtract this exponent, right? Minus 2x minus 1. Because it's a binomial, you write it in brackets, right? Multiplied by 3 raised to 2x, which is this one. When you divide powers with the same base, you subtract exponents. So subtract the binomial exponent. The binomial exponent, you'll put it in brackets that way. Right. So then you simplify. You have 2 raised to 2x plus 2. And you distribute the negative. This is negative 2x. Distribute the negative again. Positive 1. Multiplied by 3 raised to 2x. You distribute the negative here again. That is negative 2x. And then this again. That is positive 1. What do you have? This positive 2x and this negative 2x. They will cancel out. You are left with 2. And then you have 2 plus 1, which is 3. Multiplied by this positive 2x and this negative 2x will cancel out. You'll be left with 3 raised to exponent 1. And then here you have 2 raised to 3, which is 8 multiplied by 3. Now I know they said without the use of a calculator. Okay, they never said so. But then anyway, I was going to use it. 8 times 3. Don't strain yourself, guys. Especially when you are deep in the question, in the exam. You might even make simple mistakes. So don't risk it. It's not worth it. Right. So this is equal to 24. 24. That's your answer. See how nice is that? Digest it, guys. Digest it. It's a beautiful thing to work with. Now, lastly, here's a level 4 question. How would you approach a question like this one? So here's what you'll do, right? I'm going to write these things as they appear. The question says negative 2 raised to x, 2 raised to x, 2 raised to that, 2 raised to x, and the x is raised to 0, 2 raised to x squared. Now they are saying that the exponent is even, right? and the exponent is bigger than 1. So which means x can be 2. That's what they mean, right? It can be 2 or anything above, right? It should be even and bigger than 1, right? So let's start with some things like this. This is the same as x raised to 0 is 1. So this is the same as 2 raised to 1 for sure, right? And then this is the same as 1 over 2 raised to x, right? So which means this will continue being a positive number, but it will be a fraction, right? So which is this is bigger than this, obviously. And then this, if it's raised to 2, this might be like this, and this will be a 4, which goes all the way up in front there of this 2, right? And then this, when I raise it to an even exponent, this will only affect the 2 and it won't affect the negative. So this might be -4. So this stays there, right? And then now this, if my 2 is x, if my x is 2, and like this is like a very big number, so it goes in front. So now let me put them in order now. When I place them in order, first the one that is negative, it's the smallest number for sure, right? I'm going to say -2 raised to x for sure. The one that is negative is my answer, right? So since I'm done with anything that is possibly negative, let me eliminate it. I want to go to the one that is 0. Now there's no one that can give me 0 here, so I'll go to the one that gives me a fraction or a decimal, and then we said that is this one. We said this one will give me a fraction, so I'll put it here this way, right? So afterwards I'll go to the one that is 2 exactly, which is this one. This is 2 exactly, because of this is the same as 2 raised to 1, so I'll put it there. 2 raised to x raised to 0, right? This is ascending order. And afterwards I have this and this. Which one is the bigger number between the two, right? So this is just 2 raised to x, but this is that 2 raised to x and all that raised to 2, so which means this is smaller than this one. So what's following is 2 raised to x, and the last one is 2 raised to x raised to 2. Beautiful 2 marks there. So that's the last part of it. If you arrived to the end of this video, you should be proud of yourself. This was definitely not an easy video. And then don't forget to like and sub. I'll see you on the next video, which will most probably be about functions to help prepare you for paper 1. So we'll meet each other on the comments or on WhatsApp or at school. Goodbye for now and all the best.